Okay students, this class will see uh, pulley and monkey problem. Block, pulley, there is a block. On the other side, a monkey. So it's difficult to draw the monkey diagram. Okay, fine. Say a man. Is trying to climb from this rope in the upward direction A, and the mass m1 mass is m kg, and this is a fixed pulley, and it is like this, and the mass of the man is capital M. Mass of the man is capital M, and in the question it is given a man is climbing up with acceleration a1 with respect to rope. A1 with respect to rope. The question it is given, man is trying to climb up with acceleration a1 with respect to rope in the upward direction, and they are asking us to find the tension in the rope, and acceleration of block. Okay, let's solve this question. Resolve into components. Individual diagram, free body diagram, mass m, the tension is T, and the downward force is mg, and okay, this is a free body diagram of this block. Let's draw the free body diagram of man. Free body diagram is capital M, and the tension is T. So if you see carefully, the man is going, the question it is given, man is going upward with respect to a1 with respect to rope. Say the rope, how the rope goes, if the man climbs up, the rope comes down. So with respect to rope, and this is a relative velocity. Acceleration of capital man with respect to rope, which means acceleration of man bar minus acceleration of rope. Remember whatever we are doing, this is a relative velocity. Relative velocity, we should acceleration, it is that too. We should subtract vector forms. Acceleration of rope, it is in the downward direction. And acceleration of man, actual acceleration of man we don't know. Acceleration of man bar is equal to, let's take upward as a positive, towards the right as positive. So acceleration of rope is minus AR j cap, and minus of minus AR j cap. Acceleration of man with respect to rope, it is equal to how much? A1 in the upward direction. A1, it is a plus or minus, it's a plus AJ. Acceleration of man is equal to plus, it goes to the other side, becomes a minus a1 minus AR j cap. So I am drawing the free body diagram of man again. Sir, what is the necessity to write AM bar? Why to find it? Now this is in a reference, frame of reference, completely different frame of reference with respect to rope, but to problems we should solve with respect to ground. And if we draw a free body diagram of man, the tension in the upward direction and the mass mg act in the downward direction, man in which direction it goes? It goes a1 minus AR in the upward direction. Now rope, in which direction it is going? It's going, now write the equation. First let's write the equation for this. T minus capital mg is equal to capital M into a1 minus AR. This is for man. Next for block, if you see, this is small m, the tension T, and small mg in the downward direction. And what is the acceleration of the block? Acceleration of the block is equal to acceleration of the rope. You understand? Whatever acceleration the rope is pulled, the same acceleration the block is also coming up. So the acceleration of block is AR in the upward direction. Now if we write the equation, T minus mg is equal to small m into A acceleration of the rope. Now let's substitute the equations. T is equal to small m into AR plus G. If we substitute there, small m AR plus small m minus capital M into G, this is equation 2, equation 1. We are substituting equation 2 in equation 1. Minus mg is equal to capital M A1 minus capital M AR. Question what they asked? They asked us to find acceleration of the rope. Acceleration of the rope is nothing, acceleration of block. Acceleration of block is nothing but acceleration of rope. If you keep this here, small m plus capital M into AR is equal to capital M A1 minus small m minus capital M into G. Acceleration of the block or acceleration of the rope, which is equal to capital M by capital M plus small m into A1 minus or plus capital M minus small m, capital M plus small m multiplied with G. This is the acceleration of block. Acceleration of the block or acceleration of the rope. If you substitute this acceleration, let's take this as equation number 3, and in any one of the equations, equation number 2, we'll get the tension.